So our energy grid, it's kind of at a breaking point. The old system with giant power plants pushing electricity in one direction just isn't cutting it anymore. It's really struggling with all the new demands, like electric vehicles and renewable energy. And this has kicked off a huge debate about what we do next, a debate that really comes down to one big question. And that question is this: who should be in charge of your power? Should it be some big central utility company calling all the shots? Or should it be you and your neighbors and a whole network of smart devices managing things on your own? This is the core conflict we're going to dig into. So, what's really wrong with the old grid? Well, think of it like a one-way street built for horse and buggies, and now we're trying to run a superhighway on it. It just wasn't designed for the two-way flow of energy we have today. With things like rooftop solar panels sending power back to the grid, or entire neighborhoods plugging in their EVs at the same time. The big solution that experts are talking about sounds like something straight out of a sci-fi movie. They imagine this future built on what they're calling an Internet of Energy. It's a smart, flexible, decentralized grid where power and information zip around in all directions, a lot like data does on the web. Okay, so what is this Internet of Energy, or IOE, exactly? Well, at its heart, it's a system that uses smart networks to let people trade energy directly with each other. I mean, just imagine, your solar panels make extra power, so your system automatically sells it to your neighbor who needs to charge their car. That's the high-tech dream right there. Now, within this big vision, there are two main ways this could all play out. The first one is the centralized model. And as you can see here, even with all the fancy new tech, there's still one central server. You can think of it as the utility. That's the brain of the operation. It collects all the data and tells everyone else what to do. It's basically a much smarter version of the system we already have. And then you have the second approach, the fully decentralized model. And this one is way more radical. Look closely at this picture. See what's missing? There's no central server, no single brain. The network just manages itself. It uses things like blockchain and smart contracts so that all the different pieces can coordinate directly with each other. The system itself is the one making the decisions. It's an incredible vision, right? A self-managing, super efficient, peer-to-peer energy utopia. But what happens when that perfect theory smacks right into messy, complicated reality? What happens when things go sideways? Because let's face it, a major crisis, we're talking a pandemic, a massive storm, you name it, that's the ultimate stress test for any system. It really forces us to ask which of these models is tougher, more resilient when resources are tight and people just aren't available. And this is where a really fascinating twist comes in. Some research that looked at exactly this scenario found something totally unexpected. A super flexible, decentralized grid actually needs a lot of specialized experts to keep all its moving parts running smoothly. But during an emergency, those people might not be able to work. A simpler, centralized system needs fewer people to run it, which counterintuitively might make it stronger when a crisis hits. Okay, so that's the tech, and that's the crisis theory. But what about the most unpredictable part of this whole equation? Us, people. Well, a groundbreaking experiment decided to test not just the technology, but how real people actually behave when they're asked to pitch in and save energy. So what they did was they split people into three groups. Group one was the central program. For them, the utility just automatically adjusted their smart devices. Easy. Group two was the tech program. They had the same smart gadgets, but they had to use an app to make the changes themselves. And the third group, the manual program, had no smart tech at all. They had to physically get up and turn stuff off. Now you have to look at the notifications they sent out because this little difference in wording is everything. The central group got a totally passive message. The utility will adjust your devices. It's just happening. But the other two groups were told to take action. They were being asked to actively do something. And the results? Oh man, it wasn't even close. The fully automated, centralized program saw a massive 26.3% drop in energy use. And the programs that required people to do something, they barely broke 5%. I mean, even with cool tech in their hands, the tech group was no better than the group doing it all by hand. The researchers came up with this brilliant name for what they saw. They called it the Weekend at Bernie's effect. Their point was that the automated system took so little effort that even a completely passive person, or, a dead one like in the movie, would still end up saving energy. All right, so let's step back for a second. We've looked at the high-tech dream, the reality of a crisis, and this fascinating human experiment. So what have we actually learned here? What does this really tell us about the future grid?
So let's just pull this all together. Look, the dream of a decentralized grid is powerful, and we have the tech to make it happen, no doubt. But we also have some hard evidence now. In a crisis, a simple, centralized system offers some surprising stability. And when it comes to getting people to change their behavior, effortless automation crushes asking people to take action. It's not even a fair fight.
And all of this leaves us with a really tough, kind of provocative final question. We all want a smarter grid, a cleaner grid, a more efficient grid. But it turns out the most effective way to get there might not be to give people more control, but to ask them to give some of it up. So the question for you is, for that smarter grid, how much control are you really willing to surrender?